Okay, so let's get started. Today, we're going to be first doing a few surveys, polls that we're going to be finding in this link. We're going to take 5 minutes to do that because we didn't have a chance to do them last class. And then we're going to jump into discussing HTTP. This is one of the foundations of what you're going to be covering during this course. And we're going to also brush through a few web development technologies, concepts. We're going to be talking about HTML, CSS, a tiny bit about JavaScript, a little bit about Visual Studio. So some of the key components that we're going to be using quite a lot throughout this semester, okay? Let's start with this one. Some of you may have taken those surveys already. Go to this link, and by the way, save this link, because every single class you're going to be using this link quite a lot, quite frequently. So go to that link. If you have not done yet, and half of you have not done, because usually I do this in class. So if you have not done this yet, start with about yourself. Take 2 minutes there to, if you want to talk a little bit about yourself so I get to know you a little bit. My intro, I didn't have a chance to go through my intro, but I posted my intro on the website on Centennial as well. After you're done with this, accept the invitation to Slack. We're going to be using Slack. Slack is a collaboration tool. Sign up on Slack. You can sign up with your Centennial email address or with your personal email address. Whichever you use the most, I would recommend to sign up with that. And last but not least, let's do this background survey. I just want to get to know a little bit of how are we in terms of CSS, HTML, object-oriented programming, coding, okay, C# coding. Again, it will give me an idea of how the class is doing about those different aspects. So let's take 5 minutes here, 1, 2, 3. And if you didn't finish them yet, by the end of it, we can move on and you can do it throughout the class. But let's do that. Okay. You're going to see that I like timers, so I'm going to put a timer so we keep track of our time, 5 minutes, and we should be good. This is the link for the ones that came afterwards. Go to that link. You're going to see 3 links on that link, and we should get them covered now. Come in. By the way, which one is better? Is this number 1 or 2? 2? Is it? Okay, good. I need a chair here, because otherwise, grab one from there, because otherwise this will close and I'll have to keep open. Okay, so yeah, I also like this one too. Come on, 10 bits. Come on, I don't deliver, but just this time. Come on. Anyone? 10 bits? No? Okay.
Yeah. Thank you.
No problem. Again, for the ones that came in now, go to this link. There are 3 links there. Click on each one and go through it. Come on. Anyone here? Anyone? No? Yes. I have a sweet teeth too. Anyone? Next one? One? No problem. Come on, anyone here with sweet tooth? Anybody else? Come on. Yes. No? Thank you. You're laughing, so you need one. Not every day, okay? Not every day.
What?
Yeah, not every day. Let me put it. And by the way, this is not to compensate for my late day last Friday. It's not. I bring this to the very first class of everybody, okay?
That link will see me all What is that? Like that.
Okay, so if you have finished, that's great. If not, you still have till the end of the class to get them covered. The way I want to start today is really by looking at the background survey and just having a look at how we are doing as a group, as a class, when it comes to some of the web development aspects that you're going to need as the basis to what you're going to be doing going forward here. So let's have a look at the response in general. Again, just aggregated information here. So in regards to object-oriented programming, okay, majority of the class, about 75% of the class, almost 80, is comfortable with that. If you rate yourself at 3 or 3 to 1, you may want to have a look, and I can share that with you. You may want to have a look at my C# class, comp229. I'm going to share the link to the entire semester of that class. Again, it's a lot of stuff, so it's not summarized. So if you want to have a recap, you can. But again, it's quite extensive. It's not summarized. You can jump around, but it will be all there. If you keep having difficulties with object-oriented programming, let me know, and I can find some extra resources to help you out. But you're going to need that for this course, okay? C#. Okay, great. So we're doing fine. With just over 90% being between a 5 and a 4. That's great. Awesome. If you have any difficulties there, again, let me know. HTML, we're going to need that quite a lot too. So today, we're going to brush through HTML once again. For some of you, that will be basic stuff. For some of you, that will kickstart your memory again and say, oh, that's what HTML is, okay? Today is, the first 2 days are slow days. You won't see too much new stuff. Today, new stuff will be about HTTP, but after that, we're going to be doing a review. But coming next class, we're going to have new stuff all the time. Actually, before next class, you're going to be doing some new stuff already from now to next class. But more about that later. So HTML, again, we are well covered here. CSS, yeah, pretty decent as well. A few people here and here. So again, if you have any problems, I will be sharing a link to a crash course on CSS, to a crash course on HTML if you need a refresher. It's a 1 hour long. It's not my course, it's somebody else's course, but it's free, it's on YouTube, and I find it to be a useful crash course. Not gonna need a lot of CSS during this course. We're gonna be using Bootstrap. Who knows what Bootstrap is?
Like a framework for creating CSS webpages?
Yeah, so it's a front-end framework, not a JavaScript framework, just a CSS framework to make things easier to put together a half-decent, good-looking web page. Okay, so you're going to be using that, but not going to be studying that. You're going to just use it and use a few classes. Okay. JavaScript, how are you doing here? Okay, so we have also everybody quite familiar. I guess that this is because of the front-end development course that most of you have taken. We're not going to be doing much with JavaScript. We're going to be using jQuery, but that's it, and not much. What's jQuery? Anyone? What is jQuery? What is jQuery? Let me enunciate that. It's a JavaScript library. Like what? What are some other JavaScript libraries? Which one? React is another one. Angular, another one. So again, there are a lot of different frameworks on JavaScript. So you're going to be using a little bit of jQuery, but not going to be coding front end. This is not a course about front end, okay? This is a course about back-end stuff, back-end development. HTTP, okay, so that's what you're going to be covering in our first part of today, okay? We have some familiarity here, yeah, more than half of the class, but why am I going to talk about HTTP? Because it is the foundation element of what we're going to be doing with MVC here. HTTP is all about a request and a response, request and response. And that's what you're going to be coding. You're going to be coding how to handle a request, how to process that, how to spit out a response back to the client. Okay? Awesome. By the way, as I mentioned briefly before, I keep this Padlet open all class long. So in case you want to ask a question, not by raising your hands, you can ask the question here anonymously, and I'll keep flipping back and forth between the presentation and this to see if there are any questions there. So again, you can ask verbally, or you can write it down here, and I will be checking throughout the class, okay? For the shy ones. Okay, great. So what's up now? So what now? HTTP. Okay, so here's the thing. I mentioned last class, brief last class, that you're going to be having bonuses. So today, there is a bonus. In the last 20 minutes of the class, I'm going to stop just around, at 2 o'clock. So I'll stop. And then I'll give you a chance to, actually, throughout, you should write down your notes about what we're talking here. What is HTTP? And I'll be showing a diagram as well. And I'll be showing a little bit of HTML, a little bit of JavaScript, a little bit of CSS, what is a request, what is a response, what is a client, what is a server. Again, write down, maybe in a Word document, those points as I go along. Because at the end, you're going to reproduce a diagram that I'll be showing a lot of times here. You're going to reproduce that on Microsoft Word, just with some basic arrows, some basic shapes that you can use on Microsoft Word. So you're going to reproduce this diagram. You're going to write down, what is HTTP? What did you get from HTTP? Maybe it's one line, 2 lines. It doesn't need to be a dissertation. I'm just looking for one page with a diagram and with the key points of this class. You're going to put that together. You're going to upload that as your bonus number 1. You have up to 2:30 to do the uploads. After that, it is no longer considered. Okay? So that's your first 1%. Is that clear? Does that make sense? Any questions about that? Again, last class of another section. 5 people uploaded right after, the mark. And I said, can you upload that? I said, okay, I'm going to give half a point. But again, let's not do that. You're going to have pretty much half an hour to upload that, you know. So again, take your notes as we go along, and you're going to have half an hour to upload. So don't wait for, 2:29 because the system, Centennial may close, sooner after that. So again, you have up to 2:30 to upload that as your bonus number 1. Okay, I'll keep reminding you about that as we go along. And by the way, you can upload that if you go to, I'll show you here, Centennial. So if you go to Centennial, assessments, and then assignments, and you're going to see bonus 1, bonus 2. Bonus 2 I'll explain towards the end of the class. This is for next class, bonus 2, but bonus 1 is for today. Okay, so you can upload under bonus number 01. Okay, so HTTP, who can tell me what does it mean? What is HTTP? Just what's the short of what? What is that? Okay, yep, that's it. Hypertext transfer. Yeah, hypertext transfer protocol. Okay, so as I said, why are we talking about that? Because HTTP is the foundational piece of the web in general. Everything on the web is a request that someone makes to a server, and you get back a response. So you have this pair, request, response. You're going to be tired by the end of this class of listening to request, response, request. Don't think I'm crazy. I'm a bit crazy, but not that much. I keep repeating myself to make my point, to make the point here. There are just a few things that I want from each class from you. And from this class, I'm going to show you a diagram that I will be repeating this diagram so much that I'll be asking you to copy this diagram. Because again, it's the foundation of what you're going to be going through. So request and response. So you're going to be focusing a lot about understanding the details of this request and response pair as we go along. So this is the basic definition, the Wikipedia, the dictionary definition of HTTP. And I want to highlight this keyword here, stateless. Who can tell me what that might mean and what to understand about stateless? And stateless is not a word that you hear too often when we're talking about things, but in this context here, what do you understand by that? What's your a rough understanding?
It won't save the previous data in the...
Okay, it won't save the previous data. Okay, that's good. That's good direction. Anything else? Anybody else? Crickets. Stateless means that there is no recollection, there's no memory from one transaction to the next one. So when you have an HTTP request, you get a response, and that's it. The next request will not remember the previous one. Now, but you may say, well, that's how come? If I'm in a shopping cart, and I go to click next and next and next, it remembers where I am in the process. So isn't that a state? You're not making too much sense. Well, who's taking care of that is not HTTP. HTTP is just, here's a metaphor, a comparison that I like to use with HTTP. HTTP is like a truck. A truck in a highway, it knows how to go from point A to point B. It doesn't care what's inside of it. So that truck doesn't have a memory of the last trip that it made. It just knows that it needs to be from point A to go from point A to point B. So HTTP, it's doing that. It's moving loads of stuff What is that stuff? That stuff is a request. That stuff is a response. Now, inside the request, inside the response, there might be some stuff that will be useful to remember things. But it's not HTTP that is doing that. It's what's inside of the truck, of the HTTP truck. It's that message that's going inside, okay? So it's not the job of HTTP to remember. The job of remembering is the server is remembering stuff. There is information in the truck that remembers stuff, but it's not HTTP that is doing that, okay? Great. You're going to see a lot of slides here that I'm just going to brush through. I'm not going to read everything from those slides. There are certain things here that are more for your own information, but that's the diagram. So I'm going to ask you, as part of your bonus, for the ones that were not here before, by the end of the class, 2:30, you need to upload your notes about this class, including reproducing this diagram, okay? So let's talk a little bit about this diagram here. We have a client making a request to a server. The server does something here. This web application does some processing with that data, with that information, with that request. And then it returns back to the client a response. That response will have HTML, may have some CSS, may have some JavaScript on it, okay? When you say client, what is that client? Can you give me an example of a client? The user, the browser. So the user, correct. The user is using what? Is using the browser, okay? So we're talking about the browser here. Okay, so browser is a client. The user is using a browser. What other clients can you think of that could be using the web as well, like this? Think about other clients.
Other servers?
Other servers? That's true. We can have other servers here communicating with this server, so they can become clients too. That's fine, that's true, that's correct. What else? Let's keep thinking. Think about what you use in your daily lives that communicates with the web beyond the browser. Phone applications, apps, mobile apps. Yes, they are other types of clients. Database? Database, I would say that it's here. Database is here, so it can be a client of another server, but I would put it together in this side of the equation. Server, we have application, and data is here somewhere as well, okay? Have you heard about the term Internet of Things? What is Internet of Things? Give me one example. Devices, like what? Smartwatch. What else? Alexa, Google Home. All kinds of devices that we have nowadays that are communicating with the web. And you know what? They are just doing this. They are sending a request to a server somewhere and getting a response back. Now, in a device like Alexa or Google Home, the response, yes, there will be some data there, but the response will not necessarily be HTML, CSS, JavaScript. It will be what? What is it, that response? How does it look like? What was that? Numbers, okay, numbers. Here, see, in this scenario, we are returning HTML, CSS, JavaScript. Can we return other types of media as well? XML. What else? Other types of files. Let's put it this way. JSON. Okay, let's keep going. Yes, correct. What else? When you look at the website, what else do you see there? Do you see only HTML? Videos, images, okay? Audio, Alexa, or Google Home, they'll be returning audio. Alexa, play whatever. It will be playing back to me an audio file. Okay, so this response may include a lot of different types of files. Not only these, but those are the ones that we're going to be focusing during our course, okay? But I just want you to get the idea that this is how the web works. In summary, in short, this is a high level how everything on the web works. Let's keep progressing. Oh, and by the way, what you're going to be doing, not today, I mean throughout this course, is here. We're going to be focusing on this little piece here. What are we going to do when we get a request? We're going to do something here, and it will produce a response. So how we read the request, how we respond to that. That's just what we're going to do. Can you imagine? We have 14 weeks just to talk about that, just to code that. Okay. Okay, let's talk a little bit about just those two elements. Let's have a look at this video here. By the way, if I did remind you that I'm recording this, okay? So this will be available by tomorrow, and you're gonna get a link with the class today, okay? So every class I keep recording. Okay, so let's see what this is about. Okay, so this guy will be talking again about HTTP, and he will be talking about 6 aspects of HTTP, six characteristics of HTTP. Okay, so let's see what he has to say. If I get the volume to work.
Client-server model or request-response model. So I often use.
Is that too loud? Okay.
Kitchens. I always use.
Is that okay? Yeah. Okay. So I'm gonna step back here for a second.
Basic point is that HTTP follows. Wrote down all 6 points, run through them, and hope it's useful. All right, guys, let's do it. First point, most basic point, is that HTTP follows the standard client-server model or request-response model. So I often use kitchens. I always use kitchens as my analogies because, I don't know, it's really convenient, but we've talked about this before. Basic client-server model, you're a person going to eat at a kitchen, you're a client, and the kitchen is responding to your request. So you go in, I want a Big Mac. The kitchen goes, all right, here's a Big Mac. So the web browser you're using right now to watch this video, or any web browser that's running on your mobile phones, those are the clients to HTTP. And the servers for HTTP are all those web applications like YouTube, Facebook that are sitting on the cloud, owned by different companies and just on the internet. All right, so point number 1, really basic client-server model, and that's what HTTP follows. The second really important thing to understand about HTTP is that it's a stateless protocol. And what do we mean by stateless? What stateless kind of means is that every single transaction you make through HTTP is independent and is not related to any other transaction. So let's just take a couple analogies, like flipping a coin. Flipping a coin is stateless, right? Heads, 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 tails, tails. Just because you got heads 5 times doesn't mean you couldn't get it with the same probability the next time, right? Flipping a coin is stateless. So even though HTTP is kind of a stateless protocol, you'll see that a lot of web applications still track your state somehow, right? And they do this via these things called sessions, cookies, and a lot of kind of...
So as I briefly mentioned, that it is stateless, but we have mechanisms to control and to remember from one transaction to the next one. Cookies, where are cookies stored? I can tell you, not in a jar. Browser, client browser, isn't it? Okay, so again, we are storing data in the clients and sending that through HTTP. So from a client side, you have cookies. From a server side, you have sessions. Okay, so this is how the web is able to remember from one transaction to the next one. Okay?
Stateful management of how web applications work with all their clients, but that's for another video, all right? So even though HTTP itself is stateless, you still get the functionality of state through other mechanisms. So remember that. The third important point about HTTP is that it's an application layer protocol, and it sits on top of a transport layer protocol. 99.9% of the case, HTTP uses TCP as its transport level protocol. So if the transport layer is here, the application layer is a little above it, all right, in the stack of things. We can't get into the details of TCP in this video, but what it really does is it defines how data is sent from one place to the other, how the data is formatted, how the packets are sent, how do you acknowledge things. It's kind of dictating the actual transport or the communication of the data itself. That's what TCP does. HTTP sits above that on the stack, right? So from HTTP's perspective, it doesn't care about how the data is sent. Those are details it doesn't care about. All it cares about is, I request a web page, I want to get some data back. I request that web page, I want to get some data back. So it never cares about all those little details that TCP handles. So HTTP up here, TCP right below it. All right, on to the...
Okay, before I move on, so I'll go back to my analogy, to my metaphor about the truck. So think about a highway that we have trucks going from point A to point B. Trucks are carrying loads of whatever it is, of merchandise and other stuff. If we bring that comparison to what we're talking about here, we have the wires and the wireless networks, which are our highways, our information highways. On those highways, we have trucks carrying information back and forth. Those trucks are TCP. TCP is the vehicle that brings packages from one place to the other one. What goes inside of those trucks are HTTP packages. They might be a request, they might be a response. That analogy usually works better, at least for me, to visualize what this is about, an application layer and transport layer. So again, I like that analogy. I don't know if it helps, but I like that.
The fourth important thing about this protocol is that whenever the client requests something from the server, it always specifies a special action or method along with it. If you're a developer watching this video before, I'm sure you've heard of all these different methods or actions. Get, post, delete. But these are all special actions to be performed by the server. Get is really simple. I just want to get a page, read a page, all right? It's always read only. I want to get a resource. Post is you're creating something new. So you're creating a new item in your shopping cart, or you're creating a new friend in Facebook. But post is always for creating a new object. And delete, self-explanatory. Fifth most important thing about HTTP is that it defines response status codes that the servers make back to the clients. I'm sure many of you have encountered some of these before. 200 means A-OK, 404 means not found, 500 means you effed up. But if you look at the documentation for HTTP, there's a lot of these numbers defining what all the different status codes means. But what's really difficult is that it's actually up to the programmer to return the proper status codes. And more often than not, you don't really return the proper status code many times. Okay, so the sixth and last core thing to understand about HTTP is that it supports these things called headers. All a header is, it's really simple. All headers are tiny bits of custom information that you send along with your request and with your responses. The main purpose of headers and all this custom little bits of information is to kind of tweak the operation of the request. So let me just give a few examples.
I'll stop right there because I'll be covering myself headers next. So again, I always like to give different perspectives from different voices and different people of the content that we are talking about. So we stopped right there when he was about to talk about headers, message headers, request headers, response headers. I'm going to switch to the browser here. I'm going to show you how to see headers of any website communication that you may want to try. I'll be using Google Chrome. So I'm just going to switch here to the browser. I'll go to a new page, and I'm just going to press F12, function 12. So with function 12, you're going to see either at the bottom of your screen or on the right-hand side, you're going to see this area. This area will give you a lot of details about the page and the communication that is happening when you perform a request to a website. Okay? So I'm going to do that. Right now, there's nothing here. I'm just going to type google.ca. I'm going to hit enter. When I hit enter, you're going to see that this will start to populate with files, every single file that comes back from these requests, like what? Like image files, CSS files, JavaScript files, the actual request, which is a HTML content. So I'm going to hit enter here. See, and it starts to show up. The very first one, if it's ordered by waterfall, the very first request is the one that I did, the request to google.ca. So if I click there, the very first one, on the left, on the right-hand side, I will see these tabs. The first one that by default comes selected is called headers. Here, you can see the request header and the response header. If this is too low for you, you may want to try on your own there because I cannot make this higher. Yeah, just can't. So you're going to see request headers and response headers. Now, let me tell you this. Each message, when I perform a request and I receive a response, they have two parts for them, for each message. They have the body of the message and the header of the message. So header and body, they are part of each and every single request response. A request has body and header. A response has a body and a header. What is the body of my response? What is the body parts? Where can you see the body part of the response? Let me reword. On the browser, yeah. So the page is the body part of the response. You see the body just by looking at the page. This is the body. Where's the header? Well, the header is not displayed. It doesn't matter for the user. The user doesn't care about the header. We care because we're coding this stuff. So here you can see the headers. You can see the request header, which is the first one that happens, is my request to the server, and then the response header, which comes back to me. Let's have a look and explore a little bit of each one of them. Remember that the guy in the video, he was talking about some actions that could happen. Can you recall any one of those actions? Get, what else? Post, delete, yep. So can you see here one of those right here in my screen? See, method get. Okay, so again, this is the action that myself as the client, I performed with Google. I got the website. Get means it's read-only information. I'm just getting the page back to the client, okay? No modification happens when you do a get. Actually, let me rephrase that. No modification should happen. So if you code things properly, gets are not supposed to change anything on the server. They are just supposed to get read-only information. Okay? Now, tell me about one interaction, one way that you can use a web page that you are actually changing information. When you do what? Give me one or two examples.
Form submission.
A form submission, yes. So when you fill out a form and you hit the submit button, you're going to see a message like this, but instead of method get, which method you're gonna see? Post. Post, okay, so again, get is for the read-only, post is when you need to change information, save information, change information. Delete, I don't see being used too much, so you're going to be focused really on those two, on this pair, on get and posts, okay? Get for read-only information, post for changing information. And you can see in the header that you have tiny bits of data here. you have pairs of data. You have a property and a value. Like you have methods get, authority, google.ca, path slash scheme, HTTPS. So again, you have those tiny bits of information, of pairs of information. Okay, property and a value, property and value, property and value. Okay, so am I going to go through each one of you or each one of those and ask you to cite them back to me? No, just want you to know that this is where you can see the headers of a request, and then let's flip to the response. Let's have a look at that. See, we also have a bunch of pairs of properties and values. Properties and values. Remember the guy was talking about response codes? Do you remember the number that he was talking about for a good response? Which one? 200. 200. Let's have a look here. Can you see a 200 somewhere here? See, status here. It's saying that when I requested, I got a response. The response was okay. Everything went fine, no errors. So I get a status 200. If there's a problem, you may see a different number here, okay? And again, as you see, there are lots of pairs, lots of values here, including, actually, let me go back to the requests just for a second. See, remember that in the video he mentioned about cookies? Cookies are a piece of data that are stored locally, but they go back to the server. Look, this is how Google track me, you, via this whole mumbo jumbo that is stored right here. See, cookie, how big it is, many, many, many lines. This is how Google, Facebook, they track us. Okay? There's a lot of information here about our personal use of our web activity. So this information goes back to Google. What they do with that information, well, God knows what. But yeah, that's what cookies are. Locally stored piece of information that goes back to the server whenever we access the website. Okay? Any questions? Any questions? Let's see if there's anything there on Padlet. Okay. Nope, that's fine. Great, so let's carry on here. So we discussed a little bit about the request, about the response. As I said, there are some slides here that I'm not going to go line by line. I'm just going to mention that, have you heard about the term URL? What is a URL? Not necessarily, what it stands for, but give me an example of a URL.
The link that shows up the page.
Yes, that's a URL. So a URL is a unique identifier for pages, for website addresses. A URI is something a little bit more abundant, more comprehensive. Like an email address is an example of URI. An FTP address, who knows what FTP means?
File transfer protocol.
File transfer, and it's used for what? To transfer files. Good. So yeah, so FTP is an example of a URI, but FTPs are not URLs. Okay, so this is just a slide showing how the URLs are organized. What is it that the different elements of a URL? You have HTTP, column. Nowadays, you don't see much HTTP anymore. You see HTTP, S. For what? S for what? Secure. So again, we have secure communication, encrypted communication between the client and the server. It means that if someone is sniffing, is looking at the packages, they won't be able to easily decipher what's going on. So it's encrypted, okay? And then again, this is just showing how the URL is formatted. You know, we have hosts, that is the google.ca, centennialcollege.ca, this is the host. Port number, who can tell me what is the default port number of websites, of pages in general? What is the default one? 10?
80.
80. 80 is the default one. Rarely we see a website address that has a port number because they all use 80. But if you see a URL with a port number, it means that they are not using the default port number to communicate with the server, okay? And again, you have more elements there. You have the slash, forward slash, and then the path. You can have more information on this link here. By the way, both slides that I'm going to be showing today, they are both available already on week number 1. Is that week number 1? Yeah. I have to place them on week number 2 again. But they are placed there. Just showing a little bit of the message format. This request format, response format, it has 2 segments. One is the header. Sorry, it starts with a start line. It has a header. It has a what is this? What is control R? What is that? What does that mean? Well, it's carriage return and line feed. But what is that? Translate that to plain English.
Like an enter key?
It's a line. It's an extra line. It's a key line. So again, it has a header, start line, header, and then the message body. Let's not confuse the message. See, each message, they have a header and a body. This body is not the HTML body. Okay, so we still have the HTML body to deal with, but we're going to talk about that once we get to HTML. This is, again, just showing a little bit. I don't want to hammer into this. Let's just keep moving forward here. This is a list of messages, of types of messages that you can have with your requests. We saw the get with the request we made to Google. If we post a form, if we submit a form, we are doing a post. There are a bunch of other verbs. This is also called verb. If you hear the name verb, it's the same thing as a method, okay? Verb and method, they are terms used intertwined, okay? Great. Let's have a look at this quick video here.
HTTP is an acronym for Hypertext Transfer Protocol, literally a protocol used to transfer hypertext, which begs 2 questions. What is a protocol, and what is hypertext? In this context, a protocol is a system of rules that allow communication of information between different entities, like computers. Hypertext is a somewhat outdated word for text that is displayed on a computer screen that contains hyperlinks to other text, so web documents. So, the Hypertext Transfer Protocol is the set of rules servers and browsers use to transfer web documents back and forth, which is why every URL you type into a web browser starts with HTTP. That's a nice definition, but it doesn't tell us much about the nature of HTTP, what it is. So let's dig in a bit deeper. One of the core principles of HTTP is that it is plain language and human readable. When you see an HTTP request, response, or message, you can read it out loud and make sense of it, even if you don't necessarily know how the technology works. As an example, all HTTP request methods use simple human language verbs: get, post, put, delete, and so on. You don't need to know anything about computers or computer networks to get what I mean. Another principle is that HTTP is a stateless protocol. That means each individual request sent over the protocol is unique, and no request is connected to another request. To put it in another way, HTTP has no memory of previous requests. Go to a web page with a photo gallery, and it'll show you the first picture. Go reload your browser or type in the URL again, and you get the first picture again, because HTTP has no memory of you making that first request. This statelessness ensures users don't get trapped in or placed in the middle of sequences of content, but it also means they can't walk their way through sequences because the requests are not connected. To fix this, HTTP allows sessions, stored states shared between the browser and the server. If a visitor is flipping their way through a photo gallery, the browser and server can exchange information about where the visitor is in the sequence by passing information back and forth in the form of cookies. Reload the page, and the browser sends along a cookie to the server saying, hey, last time we spoke, we were looking at the third picture. Start there. This means while HTTP is stateless, it is not sessionless. That passing of cookies that allows HTTP to preserve sessions is made possible by the extensibility of HTTP. When requests and responses are sent back and forth over HTTP, we can include HTTP headers with additional information. These headers can carry information about everything from what type of client sent the requests, the server configuration, and the time and date of the response, to how and for how long the client should store the data, what format the data is in, those cookies used to track sessions, and so on. Which brings us to the last basic principle. HTTP works based on request-response pairs. Every action performed over HTTP starts with a request using one of the HTTP methods and ends with a response containing an HTTP status code saying what happened to the request along with the data like headers and content.
Perfect. So again, more of the same in a way, but I think it's useful to recap. So, question. Do we need a break? Do we need a 5 minutes break between the first hour and the second hour? Come on, give me some. Yep, so let's do that. 5 minutes. Come back in 5 minutes. Yeah, sure. Sure. Let me just put this timer here so we can control this a little bit better. Okay, go ahead.
This one, but
Yep.
for some reason I don't have this.
Okay. You want to put it here? Because, again, so you don't have that template. So which version of Visual is this one? It's 2017?
Yeah, but it's community.
Community. Okay, so here's the thing. I will be showing how you can download the full version via instantaneous resources. I'll be showing today. I'll be showing that. So again, before the end of the class. Yeah, because this version may not have the template. Sorry, and we're not going to be using the template that much, to be honest. But I'll be showing how you can download an enterprise version of Visual Studio.
Actually, I have another laptop.
Okay.
I downloaded from Instantaneous
Yep.
into Premiere version, but is it okay? Because
From another laptop?
Yeah, as far as I know, I can download just one time. No. Maybe
I don't think so. I think that you might be able to download multiple times. I don't. Give it a try. Give it a try, okay?
Yeah.
And let me know. Maybe, I mean, if it comes down to that, maybe you uninstall from that one and just install this one, the one that you're going to be using. But give it a try and try to install them both. I think it should work.
Yeah,
Okay?
Anyway, we are gonna do this today, right?
Well, I'm not gonna be walking you through. I'm just gonna say, here's a document that Centennial provides, so you can follow, you can download, and you can install. But I'm not gonna go step by step with you. I'm just gonna give you a resource, and then if you have problem, I mean, we can see if we can work out. But again, I'll just give you the guide on how to do that. Okay?
Okay. Yeah, thank you.
No problem. Come on, 2 10 bits. That's it. 2 lucky ones. It's not from me. Come on. Yes. Kim. 11 bits. Okay, take both. Don't make me go back.
Thank you.
Yes.
Is there any application that we're gonna use it in this course, we have to download it, except the Visual Studio?
Not really. No. There's one element of Visual Studio that you need to make sure that it's installed. It's called LocalDB, but I'll be mentioning today. There will be a few minutes that I'll be talking about Visual Studio. I'll mention that.
And we don't use the FileZilla, right?
No, we won't be uploading things to anywhere. No, we are fine without that.
Like the assignment just in...
Assignments just to show me on your laptops or on the stations, and you upload the code to Centennial.
Okay.
Okay?
Okay.
Okay, so let's carry on here. Just want to do to mention a little bit about the status codes that you can receive from the server. We start with the 100 series, which are just informational status codes. To be quite honest, I don't come across of this type of codes too often. Then we have the 200s here, which is a successful code. We have seen that on our browser when we got the response, we got a 200, meaning that it was successful. And then there are some subtypes of the successful ones, like these ones. Okay? We have a 300 redirection. What is a redirection? Redirection of what, from what to what? I mean, what is a redirection?
Moving to another page.
Moving to another page. When we would see that happen, why are we moving to another page? Why is that? Any ideas? Yeah.
The web page doesn't exist anymore.
It doesn't exist anymore. Maybe the website was rebuilt, and now we have new URLs. But if our website is old enough, there will be links out there pointing to that old stuff, to that old place. So we don't want to break those links. We want to redirect them to new locations. That's when the redirection comes to place. We're going to be redirecting from old URLs to new places, telling that, oh, this used to be here, now it's there, okay? And then Google, for instance, Google will update its index automatically if it comes across a 300 code. It will update its index, and we want that. As site owners, we want to have our sites point to the correct location. Okay? And we have the 400 series, which are client-side errors. Those are errors done from the clients. I mean, maybe we have requested a page that does not exist. If I go to a broken link, it's called a broken link. If I see a link that goes to a page that doesn't exist, it's the client that is causing the problem. The server is not the one responsible if you type in something in the browser that does not exist. So those are client-side errors. Now, we also have server-side errors. 500 errors? As the guy said, it means that something happened in the server side that caused an error. You didn't handle, as a developer, for instance, you didn't handle an error properly. You let the application crash, and then it comes back as a 500, 501, 503, anything like that. Okay, let's go to this link here. When you see your turn, you have to do some action there. So open on your browsers, open nearpods.com. This is the website. And when you open that, I'll show you here the website's address. So the website address is nearpods.com. And when you go to that site, at the very top it says codes. Enter the codes. This is the code. I'll give you 2 minutes here. It's just 3 questions to get them done. So again, nearpods.com, and the code is KHXIY. You're going to see a quiz. I think it's 3 or 4 questions. And let's just have a look at there. Okay, so let's have a look together at that. So we have 3 questions here about HTTP. The following are all parts of HTTP messages except footer. So we have headers, we have body, we have a start line, beginning of the message, but we don't have footers. What is the name of the transport protocol used by HTTP? TCP. What are the 2 most common HTTP methods? Get and post. Again, the other ones are still very useful, very relevant, but those are the 2 ones that we're going to be focusing the most during this course here. Okay? Okay, so let me move to another 4 questions. So let me hide the student's name. Yeah, so we are doing all good here. Let's go through yet another 4 questions about the same subject. Go ahead, I'll give you 2 minutes. In the meantime, I'll take attendance here. So, Vandana? Martha? Muhammad Ali? Natalia? Danish, how? Danish? Avijit? Curtis, Edison, Edison, yep, Edison, yep, that's it. Ederson, almost, just by a little bit there. Eunsiok, Ion, so did I pronounce right? Okay, I'll try. Richard, Chiodes, Kenneth, Ken. Amodeep, Manau, Diego, Hayun, Jared, Vadim, Chrysil, is that a Chryzel, sorry about that. Shaniqua, yep. Vladislav, yep. Andre, Chaudhuri, Saida, Harbin, Hassan, Muhammad Shibli, Tosh, oh, sorry about that, Josh, my mistake, Josh, Shuyun, Hun Xiong, last name YU, is it yours? I know that I messed up your name, so how do you pronounce? Huansong. Huansong? Okay, I'll try to remember. Okay, so let's carry on here. Did anyone I didn't call your name by any chance, or I called wrong? Okay. Okay, so let's wrap this up here. So, which of the following is a characteristic of HTTP? All of them. Stateless. It does not keep state between the sessions, between the requests. Request and response pair. It has a status code when it comes back. All of the above. Is the HTTP request method or action used to send data from the client to the server? Post. Get is read-only, okay? Get is only to get information. We are not sending anything. Think about yourself as the client. You post information, you send information from you to the server. When you get, you are getting from the server, read-only information, okay? What is the most common HTTP status code? 200, hopefully, because otherwise we'll be in trouble. And last one, what is the HTTP status code for errors? 400 is for what? For client errors, 500 for server errors. Awesome, and we are doing good. Hopefully the ones that did not get everything right, that makes sense now. If it does not, let me know. Okay, so let's move on here. Just a few links that you can have a reference about HTTP. Again, this is available for you to download. And a quick summary. Back again to our response request. A client sends an HTTP request to the server. The web server receives the request, runs an application there to process, returns back. The server returns an HTTP response and output to the web browser. the client receives a response and it displays in their browser window. Okay? Great. So there is a second part to our conversation today. It's a bit of an introduction to web development. Again, my intention is not to go through all the details of HTML, of CSS, JavaScript. Actually, there will be plenty of stuff that I'll be just brushing over. But I want to start with something that I think it's key, so I'll be skipping a bunch of stuff initially. I want to jump to Visual Studio because I want to mention a few things about Visual Studio before we proceed here. So let me go to the very bottom of this. Okay. So Visual Studio is our IDE. What is our IDE? Integrated Development Environment. Okay? So we are using, as a reference point, Visual Studio 2017. Ederson, are we studying in an outdated environment? Not really. The book is based on 2017. The content in general is based on 2017. However, the same applicability, the same things that you're going to find on 2017 when it comes to this course, you're going to find the same things on 2019. At some point, the book will get updated. At some point, the content will be updated as well. But we are using 2017. Again, you will not have a problem in case you are using 2019. You can use 2019. That's fine. Okay? What I want to mention is how you get it. I mean, you get on your workstations. That's great. It's all there. But if you want to download, you can download from, you can find a link on Centennial that you can log in as a student, and you can download to your own laptops, computers there. So I've posted this PDF under Content. Go to General, and here you can find Download Visual Studio 2017. It will show you step by step on which sites you have to go and log in to be able to download Visual Studio. But before you install it, make sure that you check this link here, because it will show you which option you need to click to check to make sure that you have LocalDB installed together with Visual Studio on your environment, because you're going to be using databases, and you're going to be using LocalDB as a simple database to store and retrieve information from. Okay? So again, check this link to make sure that you check the box that says install LocalDB. I had questions on other sections about Mac users. So Mac, you won't get this LocalDB, unfortunately. Okay? So you have to find your ways, maybe with Plesk, oh, not Plesk, sorry, Parallels, maybe some other way. I know Parallels is slow, but yep, I mean, we're going to need something like that to do the applications, okay? I think that's the only reason why it would not work on a Mac, is because of this one here. Any questions about that? Okay. Okay, so see here. Okay, so I want to go all the way back. Yeah, I'm gonna skip. I'm gonna keep to the most relevant stuff here. Let's just brush through a little bit of HTML here. Okay, as I said, we're gonna need some basic understanding of HTML to be able to output our content. What is HTML? Is the markup language. It can be used on any editor, but our editor of choice is Visual Studio. Again, HTML is one of the many components that you're going to be returning in our response. Okay, HTML will be, if you look at MVC. By the way, what is MVC? What does it stand for? Model View Controller. Again, a very different way to do programming as compared to a more traditional approach of coding, okay? But HTML, in our case, in our MVC, it will be included in the view part, in the view element of our MVC. Views are made up of HTML plus something called Razor scripts, okay? You're gonna see more about that as we go along. Again, as I said, my intention is not to give a crash course on HTML. There is a link for that. I just want to brush through a few things. HTML is built up of tags. They have an opening and a closing. Some tags, they have content on them between the opening and closing. Some tags are empty. You close a tag with the /. Can you give me an example of an empty element of HTML? Paragraph. Paragraph, we have an opening tag and a closing tag, and then we have content between the two of them. So it's not empty. Anyone? Body. Body as well. We have an opening body and closing body. There's a lot of content. Break, line break, the BR. There's no, we have the closing is within the same tag, okay? So again, empty elements, it means that the closing tag and the opening tag is within the same one. What other element is an example of an empty element? HR, image as well, because the image path is a property, okay?
What about
Source.
if you want to link the JavaScript with the
Script, you mean script? Yeah, so script, we can have a script, we can have JavaScript inside the text.
Yeah.
So it can be empty, but it can also work without being empty. You can also embed JavaScript in between an opening script and a closing script. So it can be empty, but it can also not be empty, okay? Okay, so a few tags. Let's just have a quick look at this video here.
In this video, you're going to learn about using HTML to add structure to your web pages. HTML stands for Hypertext Markup Language and is found on all websites across the internet. There are a bunch of different HTML structures you can use on your web page, including headers, lists, paragraphs, links, and images. Let's take a look at how to create a paragraph in HTML. The sentence we wrote for our web page would look better if it was distinctly different from the title of the web page. To separate the two, you need to let the computer know that all of this text is a part of a paragraph and not the title. You can do this by creating a paragraph element. Most elements are made up of three main parts: an opening tag, the contents to be displayed, and a closing tag. Tags are a part of HTML language, and they signal to the computer the start and end of an element. In this case, it's a paragraph. Tags let the computer know what we want to display on the screen and what we don't want to display. That's why tags include special characters like the less than and greater than to distinguish from the content. Paragraphs are just one type of structure you can use in a web page. Soon you'll learn about a number of other structures that will give you even more power to customize your website.
Okay, again, for most of you, nothing new there, but I want to do a quick recap there. Again, most of these slides are about some basic things on HTML. I'm not gonna stop on too many. We have, again, just want to highlight that a message, a request and response, we have headers and body. But the HTML itself, it has a head section and a body section, okay? But the entire HTML comes from within the body part of the big message. So the response looks like this. Here's a response. We have the header of the response. We have the body of the response. In the body, we have the HTML, which has a head, which has a body of its own. So it's a body in a body, a head in the body. Did I confuse you enough? It's not that hard, I think. Okay, so what is parsing? Parsing is the process of when we get a response from the server, the browser gets that HTML, it parses it out, and it shows up on the browser. That's called parsing, rendering, okay? So again, just a few basic stuff there, HTML. Okay, what is a well-formed HTML document? It's a document that has, it's an HTML content that has a few things, a few elements properly in place. Like it has a doc type at the very top, it has a HTML root element. Even not well-formed pages can be displayed properly because browsers are very smart. However, if a response does not have those elements, it means that it's not well-formed, and it may look broken on certain devices even, on certain outputs. You see, to be well-formed, it's case sensitive. You can create tags, uppercase, lowercase, not a problem. However, if you do it uppercase, it's not well-formed. It does not meet the qualifications of a well-formed HTML document. Again, if you want to get more information about HTML, there is this crash course. The link is there. The link is active in your PDFs available in Centennial. It's 1 hour long. It's not done by me, but it's a good overview of HTML if you need that. If you don't, that's fine. I'm not going to go through some of those exercises because, again, it will just cover some basics of HTML. And I want to give you time to do your first bonus, and I want time to explain bonus number 2 as well. CSS. Again, not going to, go into too much details. I actually want to jump to this quick video here. It gives a good overview of HTML in general. Sorry, CSS.
Trust you have. As you've been building your websites, you learned to use HTML to give it structure. We've learned to define headings, lists, paragraphs, and images to make your website start to look the way you want. But usually just giving a website structure isn't enough. You want to give it style to fully bring the content to life. The same website about fitness could have a sleek and simple style or a quirky and eclectic style, and each would feel different to your user. Web developers can control the style of a web page using a language called CSS. CSS stands for Cascading Style Sheet. CSS allows a web developer to define a specific set of style rules to apply to HTML elements on the page. Let's take a look at how to use CSS to create style rules for a simple web page about fitness. First, we'll write the CSS to turn all the paragraph text purple, to indicate that we want to apply a set of rules to all the paragraph elements. We write the name of the tag P, followed by an open, and then a closed curly brace. We refer to the P here as the selector. The selector indicates the type of element the style rule will apply to. Next, we need to indicate what about the paragraphs we'd like to change. In this case, we want to change the color of the paragraph text. This part of the rule is called a property. And color is just one of the many properties we can change about a paragraph. A property is followed by a colon. Finally, we need to specify the value we want for that property. To make the paragraph purple, let's add the word purple after the property. And finally, add a semicolon to indicate the end of the style rule. The CSS that we just wrote is called a rule set, because like the name implies, it's a set of rules to specify a style for the selected element. We can add multiple property value pairs to the same selector to further control the style of our web page's paragraph elements. If we want these paragraphs to be purple and large, we can add the font size property to control the text size. Then specify a number value to set how large the font will be. CSS allows for all sorts of style rules. Fonts, positioning, size, and colors. The more style rules you learn, the more you can make your web page tell the story you want.
Okay, just want to cover one more aspect here of CSS. Again, one more of the elements that gets returned back to the server after a response, back to the client, sorry. I want to have a look at this. We have three types of CSS, of styling. We can have inline styles. What is an example of an inline style? It's inside of the HTML code, more specifically inside of what? Inside of the tag, okay? So that's the first one. Then we have internal style sheets. What is an internal style sheet? In a block, in a style block. Inside HTML, but in a style block. To be quite honest, those are not very efficient, effective ways to use styling, to use CSS. The third one, my opinion, is the best one because of several reasons. Can you give me one example of one reason why external style sheets are better than internal ones?
You can use them, you can reuse the file.
You can use in multiple places, in multiple pages. You can reuse them. What else? More organized, yes. If you are working in a team, you can easily say, hey, here's my CSS. You just use that. More organized. What else? Let's think about performance. What benefit can be related to performance here?
It can be loaded once and it's going to be applied in different parts.
Yes, it can be loaded. So the first time that you access a website, everything comes back to the client, to the browser, including external CSS files. If that same CSS is used someplace else in the site and you move to that page, there is no longer the need for that file to come back because it's already cached. It's already cached in the local browser. So that's called cache. When the file gets stored locally, it gets stored in the browser's cache. Okay? Awesome. Okay. Again, if you want more information about CSS and if you want to have a crash course, this is a link. Okay. JavaScript, I'm not gonna go through JavaScript. That's fine, because we will not be covering much of that at all. Now, I would like to jump to. First, I want to give you time for the bonus thing that I have been talking about, but I want to explain you already bonus number 2, because once you get started with bonus number 1, if you are done, you can just leave the class. That's fine. Again, you're gonna have until 2:30 to upload that. Bonus number 2 should be done before the beginning of, not next class, next class, Friday. So before the beginning of next class, we should be done with bonus number 2. Bonus number 2 is not just about the bonus. I want you to have that in mind. It's not just for the points, it's for the class. It's to be ready for next class. I use something called flipped classroom quite a lot. Does anyone know what is a flipped classroom? A flipped classroom is when I'll be asking you to do some upfront work before the class. So you don't have homework about what we cover in the class, but about what you're gonna cover in the next one. Because you have to be ready for next class already when you come to class. Okay, so here's how we're gonna do this. Under week number 1, and again I screw up here the weeks, because this should be Friday, but I'll fix that. You're gonna see under for next class, week number 2, you're going to see follow and practice the first 3 videos of this series. We have 6 videos here. So if you expand, you're going to see 6 videos. I'm just asking you to go through the first 3 videos. The first 3 videos in total, it has half an hour. It's about an exercise called party invites that you're going to get exposed to MVC with that exercise. Follow through it. I was the one that put the video together. This exercise comes from the book. So follow the first 3 videos. Write down at least 3 questions from the videos, but execute them, do them. Open Visual Studio and go through them, because that will be required for next class. Next class, you're going to start from here, okay? If you come to next class without that done, you have to do as the first thing during class. So we're going to be moving forward, and you're going to be doing these 3 here. So again, it will take you about, it will take you about 1 hour to get this done, to go through this video, because you're going to be pausing, and you're going to be doing, and you're going to be looking. Okay, question?
For the next class, should we have the ready code of 1 to 3 videos, or could we do them like from the first one?
The whole point of going through the videos is for you to do the codes. So you're going to be opening Visual Studio and do the code. Do you have to upload the code? No, you don't.
I mean, you said that we will start like from the first week's video.
Yeah.
We will do them. So when we come to the class, we should have our projects.
Yeah, you should have gone through this, and that should be available either on your laptop or available in a way that you can work. You can continue working on that as we go through the class on the workstations or via your own laptops. Okay, does that make sense? Okay, any other questions? Again, I do things in a different way, and I'll be doing that quite a lot, asking you to get ready for next class. You should, and the bonus is just a plus for you to get ready for next class. If you're not ready, I'm going to have a role in the class for the ones that get not ready for the class, so you can get ready for the class. Also, because you're going to be using a lot of video here, not everything will be video, but quite a few things, bring headsets. Because then you can follow through things on your own if it's time to follow through a video. So bring headsets so you can listen to. Does it have to have a microphone? No, but just headsets. Because then you can do things on your own and on your own pace, and you're going to see how this will work. But again, 3 questions from the 3 videos. Upload them under bonus number 2 on assessments. This is your ticket. I will call this a ticket for next class. This is your ticket to come in to next class. You have to have those 3 ready.
You mean the next lab class, right?
The next class, Friday. Yeah, Friday. Friday, you're going to be starting this on, okay? So again, next class, Friday, okay? Again, next half an hour, 20 minutes actually. Do bonus number 1. I will keep this diagram open so you can use this as a reference. Where is it? Right here. Okay, so again, reproduce this on your own. Don't take a print screen, because it will be too easy. The idea is you just draft that on Word, get each one of those elements, write down what you understood about that element. What is a request? Maybe what is a request, or maybe the comments that you have about requests, response, what is a client, a server, a web application, maybe HTML, CSS, JS. Again, drawing down your notes. You have the next half an hour to do that, okay? Any questions? As you go through, once you are done, you can just leave the class. That's fine, and I will see you on Friday. Yep. Yeah, I can go there.
I have been making notes during this
Yep.
semester. Can you just upload this?
Awesome. That's awesome. Okay. Yep. If you need to draw it,
Do we need to draw this?
that's the idea.
Okay.
Because then again, it will stick better right here. Sure. What's up?
This was not for
Yeah, that's okay. You can just copy that, paste on Microsoft Word, because you still need to do the diagram. You need to draw the diagram. Okay? Yes. Yeah.
We need to draw something. Oh, something like this is okay.
You can copy that Word document, that content, paste that on Word, and then, because you still have to draw the diagram. Again, reproduce the diagram, draw the diagram on your own there. Just with shapes and forms, and that's it. There are plenty of shapes there that you can easily draw this diagram and put that together.